Welcome back. Once again, kind of finishing up our series on getting a full model through kind of the engineering process, right? The final process. The last couple of these will focus on post-processing. And the post-processing is out of the way. That's annoying. Okay. The post-processing, we've started to bring a lot of that, some of that back into HyperWorks. Okay. So I just have a bulk data file loaded, just nodes and elements, loads and boundary conditions. You can look over here on the model browser, nothing super exciting. But what is exciting is I see that I have this little post ribbon up at the top. I click on it, I get all sorts of plots and all the things that you would expect have, indicating that we are going to do some post-processing. So today we're just going to kind of do some of the introduction, so making a contour, vector plots, describing some of the philosophy behind this, and as well as I want to introduce some of these query tools, because I know with Arrow we're running hundreds, thousands of load cases. A lot of times you just want to dump all of this data into Excel, into some kind of standardized format, and post-process on your own time. So all that can be done. But first we need to bring some result files in, right? So very much how we would go and say import, models or geometry or anything else. We now have the ability to import results. I guess we don't now have the ability. We've had this ability, this is what it is. I'll go and find, I have several OP2 files here, so I'm just going to grab these. I'll quickly point out the file types that we do support. So obviously OP2, XDB, HDF5 are going to kind of be our bigger ones, and then some Abacus and ANSYS results. I'll just multi-select, shift-click, grab all four of these, excuse me. What I see is I have a new results entity within my model browser, and it automatically opens up the results tab, in which I can start to see the files that are listed, right? So these can be multiple OP2 files, they can be XDB, they can be whatever they'd like. And in each of these files, I have particular subcases or load cases as well. So another way to do this, there's a little plus button on the results icon that will allow you to import or add more results. You don't have to do this all at once. You can do a couple and then add some more result files and add more result files, et cetera, et cetera. Next thing that every stress engineer loves to do is to make a pretty rainbow plot. So we're going to go ahead and put on a contour. Okay. Go ahead and select the contour button. And this is going to start to be a little bit of change in methodology. Even if you've used some of the post-processing tools that Altair has in the past, they've always kind of been a one-time, you do them, and then if you want to change, you essentially lose what you've done to incorporate the change, right? So what I mean by that is let's make a displacement contour. Okay. So I'll name it displacement. Data type is displacement. Pick your magnitude, et cetera, et cetera. If you'd like to select certain components, you most certainly can. You're only looking at a small subset of your model, but I'll just kind of leave, the minimal input to this, and I'll just go ahead and select plot. There you are. And I will go ahead and get my contour with a legend over here on the right-hand side. Now back to what I was saying, if I wanted to go and put say a stress plot on this or some other type of coloring, some other contour, I'd be forced to go back and essentially forget this displacement contour. Okay. But not anymore. So what we're adding now is this ability, we call these plot controls. So I can have a very particular type of contour for displacement, but then I can also go and say, well, add a new control for stress. Mises. I'll pick my stress. Mises. Again, you fill out all of the information. This is the information that gets lost if you wanted to say go back to displacement or go to something else. None of this gets saved. Go ahead and hit plot. Right here. I have a bunch of elements that don't necessarily conform to von Mises, but okay, this. So on these shell elements, I now have my von Mises, and it's very easy for me to just go back to displacement, right? So normally this is the data that gets lost, right? I would only be able to have one contour living in my model. I couldn't, quickly switch back and forth between them. So the idea here is to make, several different types of contour controls. You can easily switch back and forth between them to turn them on and off. Same thing with vectors, displacement. Again, you're just kind of filling out a form with how you'd like this to be done. Displacement again. Coloring modes, options here. Maybe I only want these on a particular component, so I can come and select that component. And then I'm going to go ahead and hit plot for my vectors. Here. All of my vector plots are now here. And I can have vectors alongside contour, alongside all sorts of different things. And then once again, these you can have multiple of these and toggle between them. And that's one of the benefits that we now have within this. If you'd like, all of these can be changed for subcase. So this is showing obviously the results for subcase 1. I can right click on here and say make current, and this will show the results for subcase 2, current, subcase 3, etc., etc. And then I can change back to von Mises stress. All right. So just kind of a real quick intro to what you can expect from some of this results. Some of the post-processing vectors. I won't worry about tensors, but same thing here. Deformed plot if you'd like to do that as well. And we'll talk about beam stress in another episode. But this is kind of a new paradigm shift, right? A few other things that you're probably going to be interested in doing with all of these is go ahead and look at these. Go ahead and turn my vector plot off. Look at the legend. Okay, so the legend in and of itself is going to be an entity. It's not currently, but within the newer releases, there will be a legend entity, and then this could be rinsed and repeat across all sorts of different contours. But the legend is live, so it does have the ability to come in and change values at certain thresholds. So you can just click on any of these values and type in a new value, and it will get scaled accordingly. You also have the ability to right-click on the legend. 99% of stress engineers love their rainbows, so we put you in what we call a divergent plot to start, which is just really essentially two colors, good or bad. But everyone wants a rainbow. But once again, right-clicking, you'll have all of your options for numeric precision and format, number of levels. So if you would like more rainbow, give yourself some more levels, things like that. All right. So that's kind of the real quick introduction to some of the initial post-processing. So full transparency, some things that are still missing. We don't have the ability to do animations within HyperWorks. So if you wanted to see, this airplane flap its wings because the wings are displacing, we don't have animations quite yet within HyperWorks. We'll be able to put on a contour and show a deformed plot, but we don't have the ability to do animations quite yet. Perfect. The second part of today's webinar that I would like to express and show is some of the more just kind of bulk query type of things. So this is, getting plots and colors are great for pictures and great for managers because managers seem to understand pictures. But where the real engineering comes in is the actual, post-processing that you do, extracting results from this so you can actually put it into hand calc. You can actually put it into a certifiable method. The first one that I'll talk about that I like is the Matrix browser. Okay, the Matrix browser is one of the most, I don't want to say easy to use tools, but it's one of the most general tools that we have within HyperWorks. And it allows us to query anything, anywhere, at any time, essentially, which is quite nice. It has complete access to the underlying database that HyperWorks has. The Matrix browser deserves a webinar in and of itself, but let's say you have 5 or 6 elements that you know are of interest, and you would like to just query the data from them very quickly, right? So that's the idea, is just kind of, this is kind of a quick and dirty, maybe not super dirty, just quick and a little dirty type of thing. Okay. So I can go HyperMesh data. Once again, this allows me to see all of the entities that are within the HyperMesh database, so everything from nodes and elements to materials and properties. In this case, I'm interested in elements. I'll go ahead and select query. And for me, I'm really interested in these red ones and maybe these yellow ones. One perhaps. Okay. So I'll just kind of grab some elements. You can box select, you can do all sorts of things, but these are the elements that I'm most concerned with, right? This column is now green, and to me, green is always go. And that kind of indicates that these elements contain more data, right? They're not just a pretty face on top of our surface. They actually, they contain probably a material and a property, and they obviously they have some result on them. Okay, so let's try to get deeper in and understand what these elements are. I'll select the column of elements, and now I see I have more information in which to pick from. Some might even argue too much information. So I can get all sorts of different information, especially for post-processing. So maybe we're doing some buckling. So maybe the area of these elements is important. So I'll select area and I can hit query. Maybe the, I don't know, center of gravity of each of these elements is important. So I can do a little shift click and do multi-select. Okay. If I'm doing C-bush elements, maybe the spring stiffness. Maybe if I'm doing any kind of bar elements, maybe the actual cross-sectional information within there is important. So I'll just select all of that as needed, but really, really, really what we want is we want results, right? I want to know what the stress or displacement, depending on what I've selected, is for those elements. So I'll hit results. This takes me to my final box. Why are there so many boxes? I don't know. Select standard and hit query. And essentially what it's going to allow me to do is it's going to say, well, these elements, these are the load cases that we've imported from our results. So maybe I'm interested in these first 3 just for the sake of time. Once again, I'll just do a shift click. I would like to know what that contour value is for these 3 load cases for stress on MECs. I'm just filling out a form at this point, right? Max, no averaging. And then the system, okay. And what it's just going to do is it's just going to populate this browser, and the GUI is less important. So subcase 1, these are the values for those elements. Subcase 2, subcase 3, et cetera, right? So for these elements, all I've essentially done is queried the value for von Mises stress on those elements. Again, kind of a manual method, but if you're very particular about the elements that you'd like and the information that you'd like, and maybe you need something more than just results. You need areas, you need stiffnesses, you need inertias, you need some of the information that's stored within the preprocessor. You want some of that information out in your hand calcs. So this is quite useful to have, and then to kind of complete the loop, there's this fun little Excel button, which opens Excel. So I click on this, and then this essentially just ports all of this information out to Excel. You could also just export as a CSV file. So here's Excel. Here's the information that I have requested. And then what you would just do is you copy and paste these values into your hand calc sheet or your kind of approved certification method. A lot of times these are element forces or kind of SPC forces on 1D elements, bushes, SPC, reaction forces, those type of things to do your margin calculation, right? So this is kind of the I don't want to say the poor man's way. This is the very interactive way to do this. Okay, I'll go ahead and close this. Okay, so I'll close out the matrix browser. That's option one. This is if I'll say the matrix browser if you know a handful of locations or elements that you're interested in. Most of the times, though, we have 1,000 load cases. I can't go through each 1,000 load cases and find the particular element that I'm interested in, right? So essentially what we're trying to do now is, well, we would like some type of reporting. I'd like some enveloping, some kind of min-max or ranking. And that's all going to be in the little tools query. Tools is such a broad word. Couldn't have been like something else. Okay, anyway. So I have two modes here that I can kind of activate. The first one is results query, which I'm going to go ahead and show it, but the results query is really nothing more than the matrix browser in reverse, where it says, well, if you know what selection you'd like, go ahead and pick the data, anything that you'd like, go ahead and set. So if I want to know, just get a list of 1D element forces in the X direction or the X component for these three subcases. I've essentially said what I want, but I haven't said on what entities, right? Like this element or that node or this component. Then you can come and say, well, you can do all, which is perfectly fine if you want a giant, huge list of every single element 1D force X data component. Or you could do something more by ID and come and select number of selections and say, well, I want these, I guess we're doing 1D elements, so let's pick some rods or some beams or some bars. So for these 12 elements, I'd like you to organize by load case, increasing ID, and then I just save an output file. So this will just be CSV. And you can do multiple, right? So you can have all of these different options. So if you want to kind of run or you always extract certain things at certain places, this can be saved and then run in batch. But essentially, this is just a big list, big query. But it doesn't do any of the min-max ranking and enveloping, which is probably the most important thing that everyone's wondering about. So you saw min-max ranking and envelope and said, we'll just start there, Blaze. I don't care about the other one. Dokie. It's a little rude, but we'll take it. Once again, I'll select my three load cases, element forces. I'll answer the same questions. But now what really is important is this idea of what method we're going to do. So if I go and pick, let's say I want all. I want you to look at all of the elements in the model. I want you to pick the envelope max, right? So the envelope max is going to pick the highest, what are we looking at? The highest element force on every load case is going to find you the top 5 elements that define those on the 3 load cases that I've had. Perfectly fine. There's also ranking max, which will, the top, very similar, but it will do the top 5 per load case. And then there is min-max. I don't usually use min-max. It's usually envelope or ranking. Right? And then all you do is, if you want the top 5, you want the top 10, etc., etc. Okay? So this is how you can kind of do the down select. You can find the load cases that are most critical. You can rank them. You can also do enveloping as well. once again, just save the output file, save. That just makes a CSV file in which you can go and grab the course. The last thing that I'll point out as far as results go, and I know you're also probably super interested in some of the free body stuff, but that's next week's topic. The last thing that we can do within the results is the ability to do a derived load case. I have to remember how to do this. All right, so I can create a derived load case. Thought I could maybe just do this in the bulk. Let's see. Okay. Yeah, I can kind of click on the higher level result here and say create a derived load case. And really what we do for the derived load case is derived load case is you'll be able to do the either stepping, you can step result files together, you can do enveloping as well within a derived load case. I can't make a derived load case, but that's the kind of the final thing that we can do within our post-processing currently is create the derived load case. So with that, I do hope everyone's doing well. We're kind of coming to the end of this series. I'll probably add a few more episodes, but there's a good chance that this will change in